I take this opportunity with a lot of happiness to welcome you to our social studies lesson. You're very much welcome. Let's learn together. And I'm sure by the end of this lesson, you'll have learned much. You're very much welcome. I'm your online teacher Paul Puria. As we start off, I want to ask you a question. What are these? Take a look. What do you think that is? What about this one? If you can't remember, I request you go back to the previous recording about the topographical maps. So allow me to give you the answer. And before that, I want to remind you something that we talked in our previous recording about topographical maps. We say that topographical maps are very, very detailed, very detailed. And now someone might ask, what if I would want to enlarge, or what if I would want to reduce a topographical map? How would I be able to do that? And now that's what we're going to learn about enlargement and reduction of topographical maps. What is enlarging? What's reducing? And how do you think this can be done? Good. When we want to enlarge a map, the following steps must be followed. The first thing that you ought to do is you're supposed to measure the length and the width of the original map. After you've measured the length and the width of the original map, you're supposed to multiply the length and the width by 2. That is, if we intend to enlarge the map to twice its original size. For example, if the length and the width of a map are 6 centimeters and 4 centimeters respectively, such a map would measure 12 centimeters by 8 centimeters if enlarged to twice its size. Having enlarged the original map, it's equally obvious that the scale would change. Therefore, if a map has a scale of 1 to 60,000, the scale of the map changes to 1 to 30,000 if the size has been enlarged twice its original size. The features to be shown on the enlarged map should also be proportional to the required size of the map. We go to reduction of a topographical map. When reducing any map to a given size, then these are the steps that must be followed. 1, measure the length and the width of the map. Divide the length and the width by 2. That is, if you've been asked to reduce the map to half of its original size, for example, if the length and the width of a map are 30 centimeters and 20 centimeters respectively, such a map should measure 15 centimeters by 10 centimeters if reduced to half its size. We move on. You've an example of an enlarged map and a reduced map. You see, the scale for the enlarged one has changed from 1 to 50,000 to 1 to 25,000. My dear learner, I want you kindly to note this, because this is where most of our learners, they go wrong, because they tend to assume that because you are enlarging, even the scale is going to enlarge, but it's the reverse. When enlarging, the scale becomes smaller, and when you are reducing, the scale becomes larger. Good. Next, we want to know how to illustrate cross-sections from topographical maps. Illustrating cross-sections from topographical maps. Kindly compare A and B. This A, look at A keenly and look at B keenly. What do you see? What's the difference? Are they similar? Are they related? Is there correlation? Good. Let me now give you the answer. A, what we saw as A, now this one, this is what was A. A is a topographical map, whereas B, let me show you B. B is a cross section. So that's the difference. That A is a topographical map and B is a cross section. Have a look at this. What do you see? Are they related? I'm sure you're able to observe that they are similar, only that one is showing the contour lines, and then this other one is showing the relief, the highness, and the lowness of what the ground appears to be. Now, let's see step by step or how to get a cross-section from a topographical map. These are the things that you need. One, you need a ruler, a pencil, a grid paper. A grid paper is also called a graph paper. And then you need the topographical map that you want to reduce or you want to, the topographical map that now you want to make a cross-section out of it. Step one. Step one, take your ruler and measure the length of the area you want to cross-section. In this case, the length of the red line that's on your right-hand side. On a piece of grid paper, show this line. As I've shown you there, I've drawn the line on a piece of paper for the area that I want to cross-section. So I measured on the topographical map, and that length is what I've transferred on my graph paper or on my grid paper. Step two, you will have vertical axis. Vertical axis is the one that's going up. On the vertical axis, draw a line on the left-hand side. Now, for every 2 squares on the grid should be equal to 100 meters in height. And make sure you've label each 2 squares with an altitude from 100, 200, 300, 400, 500, 600, 700, and so on and so forth. And kindly note that you'll need to start with the lowest contour altitude and go to the highest. Now, you ought to have studied your topographical map, the contour lines that you saw there. Get to know which contour has the lowest altitude and whose contour has the highest altitude. So now, as you come up with your vertical axis, your calibrations or your markings should be based on the contour with the lowest and the contour with the highest, because now that's what we shall be dealing with. Step 3, using a blank piece of paper along the line on the contour map, mark the two ends and then place a mark on the paper every time you reach a contour, making sure that you mark the height of the contour. You see, on your right, I'm showing you how I've done mine. And if you can see well, is that, let me get a pointer. Good. You see, I started here by marking where I'm going to start, and I label this as A, and then here I've labeled as B. Then, now this was my plain piece of paper. Then I placed it from here to here. Then with my pencil, anytime I come across a contour, I mark it here, then I write its altitude. Remember, like now you see here, it's showing 200. So I've labeled 200. Now this is 180. So you might be asking yourself, where am I getting this? Now this contour line, it goes around and round, but somewhere it must be indicated. It will have a number. All the contour lines on the topographical map will have a number. So anytime I come across a contour, I mark and I indicate. I mark, 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 I indicate. Okay? The height of the contour. Like this 200, I've indicated 200. This one maybe might be 150. I indicate here 150. That's the height of the contour. So the height of the contour, you just go with the contour until where you'll find the height has been indicated. So I'll continue up to the time I get to point B. Thank you. We move on. Step 3. You see, this is the piece of paper that I've been marking as I was coming across any contour. Now, you take that piece of paper and line it along the bottom of your graph on the horizontal axis, as I've done here. Then I mark the corresponding contour heights to those on your graph with a dot. So like now here, the first one is 200. I'll go where 200 is, and I put a dot where 200 is. The other one is 300. I'll go to where 300 is, then I'll put a dot. So I go corresponding them that way up to the end. Then step 5, I'll join my dots with a line. As you can see, I've joined all my dots with a line. The next step is to label any relevant points. Like here, I have G Karanja Road, it's here. Then there's a peak, GK Thuo Peak. That is depending on the map that you have. My dear grade 9 learner, we've come to the end of this very informative lesson. I've been your online teacher, Paul Puria. I request, with your permission, you allow me to end the session there. As you continue learning, and in case you'll be having any question, feel free to write to me and I'll respond to your question. Share this video with your friends, with your fellow learners, so that we can continue benefiting together. Keep on tuned for more lessons and for more lessons and for more lessons and for more lessons and for more lessons.